Good day. This is our second video looking at organic reactions. We've just dealt with combustion, very simple, and now we're looking at substitution. So substitution reactions are going to happen with saturated compounds. And so our saturated compounds include alkanes and aromatics, things that don't have reaction sites. So alkanes are fully saturated. There's no double bond that can open up. And even though aromatics may look like they have double bonds that can open up, they're not. It's a very stable structure. So when we add X2, the X represents a halogen. Substitution means we're going to make two products. So a halogen is going to go on to the alkane or the aromatic, and HX will be transported away. So that's the pattern we're looking for in substitution. And here I've drawn out two examples. We'll look at one and then next. So here I had propane plus I2. I put the I2 in a structural form and I said, hey, it's going to attack this carbon. And what happens is we're going to form a bond between that hydrogen and that iodine. We're going to form a bond between the carbon and the iodine. Then this bond between this carbon H will break and the HI will run away, and the other iodine will now be stuck on our structure. And so now we can see we put iodine on the end carbon and HI has gone away. So even though we have two iodine atoms, only one ends up on the structure and one is taken away by the hydrogen that's been displaced. So we start with two reactants, two products. That's one thing that's true of substitution. And if we're naming this would be 1-iodopropane. The iodine could also have attacked the other end and made the same product, still be 1-iodopropane. And it can attack the middle and make 2-iodopropane. All those are equally correct, but the bottom line is we're more likely to get the iodine attacking the end carbons because they're more available. So we probably make both products in this reaction. Now we look at benzene. In this case, our halogen's bromine. And so a bromine is going to attack this carbon here, and this H in the Br will be taken away. And we'll just try that again. So here's our bromine, comes in, bonds to that H, and then this H carried away by the other bromine. So this is what we get with substitution reactions. You've got to understand, if I wanted to replace all those hydrogens, I could, but it would take 8 molecules of iodine. Similarly, I could replace all these hydrogens, but it would take 6 molecules of bromine. Only one atom of bromine goes on at a time in substitution.